This is Shanghai Pudong International Airport. Handling 70 flights per hour, it's one of the busiest in the world. At the end of 2017, the second C919 narrow-body airliner made a successful maiden flight here. With it, the Chinese aerospace manufacturer Comac intends to compete with Boeing and Airbus in the global market for large passenger planes. Steel pipe is a cornerstone of modern industry. The development of aircraft, motor vehicles, ships, equipment for nuclear power, wind power and rockets are all inseparable from large seamless steel pipes. But it takes a special kind of machinery to extrude hard metal billets into large seamless pipes. In Yanshan County, Chinese engineers have used their ingenuity to create a steel colossus of astonishing power. This machine is capable of producing 50,000 tons of force to extrude 40-ton steel ingots into large-diameter, thick-walled, seamless pipes. Among vertical extrusion machines, it has the largest opening in the world. In the Tianwan nuclear power plant in Lianyungang, steam turbines are running smoothly. Nuclear power is the cleanest, most efficient way of generating electricity. Tianwan nuclear power plant supplies 12 billion kilowatt-hours to the national grid annually, enough for a city of 9 million people. The low-pressure inner casing of each turbine unit is huge and has a complex structure. It's a key component in the power station, and it needs to withstand up to 9 atmospheres of pressure. High precision is needed to make it, of a level that can't be achieved without a special machine tool. Harbin in China's far northeast is some 1,400 kilometers from Lianyungang. Here, a 62-year-old factory is using a super machine tool to build the low-pressure inner casing. It's the largest machine of its type in the world, and it can carve a piece of steel the size of a freight truck into any shape. It's a 10-meter CNC planer-type milling machine, nicknamed the aircraft carrier of machine tools. A 50,000-ton vertical extrusion machine and the world's largest 10-meter CNC planer-type milling machine. These two super steel shapers have one thing in common. They were both made in China. In 1869, the world's first Renault bicycle made of steel tubing appeared in France. Since then, the engineering application of steel pipes has been ever expanding, and with it, the demand for them. The manufacturing process for a huge number of products today begins with steel pipes. China makes 75% of them globally. Yet China for a long time had to import high-end pipes, especially large-diameter, thick-walled, seamless pipes, because they can't be manufactured without a special machine tool. It took Chinese engineers 3 years and nearly 500 million yuan to build an unmatched 50,000-ton vertical extrusion machine.
I once picked up a cob of corn. I counted 586 kernels on that corn. Each kernel can become a new plant. We think of the company's technology and product development process as sowing seeds, where the harvest will be hundreds of times higher.
The 50,000-ton vertical extrusion machine has a total height of 30 meters, although half of this, the bottom 15 meters, is installed underground. In the bottom half sits the machine's hydraulic power system. Its red pipes are like arteries to transport power, while yellow pipes serve as veins to form a return flow. Its compressors, accumulators and boosters constitute a huge heart, giving the extrusion machine tremendous power. Today, the machine is about to shape a fourth-generation primary coolant loop pressure pipe. This is a central and critical component in a nuclear power plant. The coolant circulating in it is under high pressure, has a very high temperature, and is also highly radioactive. Its performance, therefore, has a direct bearing on the plant's smooth functioning and safety. Early in the morning, technicians start work in the extrusion machine's hydraulic power system, checking on its pipework. With a total piping length of over 3 kilometers, the pipework is very complex and the technicians must ensure there are no leaks. The pipes will be full of high-pressure oil once the extrusion machine begins its work. If a leak occurs, the oil will be sprayed out as a mist, which can easily cause an explosion. The consequences will be unimaginable. Therefore, they must treat every seam with extreme care. While the inspection of the underground pipes is in progress, preparations above ground are also underway. The machine's furnace is heating the steel to be extruded. The furnace's door opens and a 25-ton billet is slowly discharged. At a temperature of 1100 degrees Celsius, the furnace's heat has softened the steel to a point where enormous pressure will push it out of the machine like toothpaste. A descaling machine is standing by. Because of oxidation during heating, the billet's surface is covered with a thick crust of iron oxide. If the billet is sent into the extrusion machine now, the quality of steel pipe extruded will be greatly reduced. So descaling is very important. A hydraulic mechanical arm picks up the 25-ton billet and feeds it into the descaling chamber. With sparks splashing everywhere, the thick layer of scale on the surface of the billet is quickly removed. The main work of the extrusion machine will soon begin. Before that, however, a meticulous and thorough preparation must be completed. The next step is for a 16,000-ton billet-making machine to work on the metal. It will push into the billet like a titan kneading dough, giving its steel a more uniform and tighter texture. Now the billet, which has taken shape as a pipe, is finally about to be extruded. While the extruding machine is warming up, in Harbin, the preparations of the 10-meter CNC planer-type milling machine are also underway. It's about to make the low-pressure inner casing of a nuclear power plant's turbine generator. Extreme machining is the name given to the machining of extremely large and high-precision complex curved parts. This includes lathing, clamping, milling, planing, and grinding. A standard machine tool can normally perform only one of these processes. To machine complex shapes, different machine tools are needed. And since the cutter of machine tools is in a fixed position, the part needs to be repositioned and turned at different angles for work on its different surfaces. For a large object like the low-pressure inner casing section, each rotation requires lifting, measuring, and repositioning. This not only takes time and effort, it also affects machining accuracy. The 10-meter CNC planer-type milling machine uses 5 axes of motion for full versatility of positioning. The forward and backward movement of its gantry, the left and right movement of its slide plate, the up and down movement of its crossbeam and ram, the rotation of its rotary disc, and the cross swing of its swing head. By changing cutters, it can perform cutting, drilling, reaming, and grinding on all surfaces of the part. The crossbeam is its core component. Because it's suspended in mid-air, deformation under its own weight is unavoidable. Although the extent of the deformation is minor, cumulative error will cause deviation in the accuracy of the whole machine, even requiring its products to be scrapped. So how can deformation of the crossbeam be avoided?
It was extremely difficult at that time. I was so worried that I couldn't sleep at night.
The team conducted countless trials. Finally, a so-called pre-deformation solution became the key. First, they manufactured the crossbeam with a slight upward arch, artificially causing a prior deformation. Thus, after installation, the degree of sinking in the middle of the crossbeam was perfectly offset by the upward arch, solving the problem.
When there's a problem and others don't know what to do, I can solve it in several minutes. It gives me a sense of accomplishment.
The swing head of the machine has the nickname Finger of God. Assembly technician Liu Haiwang is installing heat-treated wear-resistant gears into it. The whole transmission system, consisting of more than 500 precision parts, must be mounted with an accuracy of less than 0.01 millimeters. This precision is necessary for the swing head to perform its full repertoire of complex and delicate machining operations. But these capabilities are not enough for full machining of the low-pressure inner casing. The planer-type milling machine also needs a smart brain, a CNC command system. This is on top of advanced features including a milling head with high torque and long stroke ram, oil chamber structure, digital modeling, dynamic analysis of its stiffness and spindle system, and creative breakpoint return technique. All of these are the result of technical challenges that have been conquered one by one.
This CNC planer-type milling machine is much more than just a larger version of earlier products. Take trains, for example. In the past, they could only run at speeds of tens of kilometers per hour. But now, the speed of high-speed trains can reach 350 kilometers per hour. The technology behind it, the difficulty of manufacturing, and the difficulty of control are completely different from the original trains. Because of this super machine's greatly increased size, all of the manufacturing processes, methods, and techniques are completely different. That's where the challenge is.
In Yanshan, the extrusion machine is still warming up. For Li Fuhai, it has been 6 years since he completed his first successful seamless steel pipe extrusion. These days he operates the machine to extrude 100,000 tons of steel ingots into certified pipes every year. Even so, every time he sits at the control panel, he is still impressed.
Look at these indicators of liquid level, pressure, temperature, and stroke on the screen. Every data change and every sound change makes me nervous because it shows whether the machine is running properly or not. We can't relax for a second during the process.
The process will soon arrive at the point where Li Fu Hai presses the control button and the extrusion machine pushes out the superheated steel ingot as a pipe. But it's not there yet. During the long process of descaling and pressing, the temperature of the billet has dropped. Once it cools and hardens, hot extrusion will not be possible.
Everything needs to be done at the right temperature.
The sun has gone down and night has fallen. The 1100 degrees Celsius furnace is blazing, and the machine's mechanical arm picks up the hollow billet and puts it back inside for reheating. When the billet is white hot again, a second descaling begins. With sparks cascading everywhere, another oxide layer is completely removed. Hours of meticulous preparation by 3 pieces of large auxiliary equipment will now come to a head in a magical moment. A layer of glass powder is spread evenly over the surface of the billet. The glass powder will form a lubricating layer between the billet and wall of the working cylinder of the extrusion machine, reducing friction during extrusion and helping to shape the steel pipe. Now the moment has arrived. The mechanical arm feeds the hollow billet into the extrusion machine. A few minutes later, a colossal force of 50,000 tons starts pushing the billet out as a long cylinder. At 3:47 a.m., a pristine seamless steel pipe starts to rise above the working cylinder of the extrusion machine. In just a few minutes, the 13-meter-long pipe is perfectly formed. After a steel pipe has qualified for a birth certificate, it also needs a health certificate. Has the 50,000-ton vertical extrusion machine given it the strength and integrity needed for its intended purpose? The answer will be revealed. Ultrasonic flaw detection and eddy current testing will be performed on the newly made pipe. High-temperature creep tests and mechanical property tests will also prove that its structural integrity and quality are impeccable. In Harbin, it's late at night. Inside the machining workshop, work on the steam turbine low-pressure inner casing continues as normal. Jiang Lishang, the chief operator of the CNC planer-type milling machine, has 27 years of experience in the field. Once assembled, the turbine's casing must be completely airtight, impervious to the high-pressure, high-speed steam racing around inside it. This requirement can only be met with extremely high precision in the manufacturing process. Studying the process documents is the first step. Jiang Lishang's team must scrutinize them carefully to make sure they're clear about every detail. It's like making a battle plan. There is no room for negligence. One deviation may result in flaws and the scrapping of the whole expensive piece. To be machined, the low-pressure inner casing section has been placed on the workbed, and the next step is to install tool bits. The tool bits must be carefully chosen. Different processing steps require different tool bits. Cutting needs a cutting bit. Drilling needs a drill bit. And reaming holes needs a boring bit. Once the programming is complete, machining begins. Precision is something Jiang Lishang is finely attuned to. Although the planer-type milling machine is equipped with a clever CNC control system and nimble swing head, to make this 1,000-ton machine achieve an accuracy error of less than 0.02 millimeters, or a quarter of the diameter of a human hair, is still an extreme challenge to the operator's skill.
I was deeply impressed and in awe when I saw it for the first time. I thought that I'd be very proud if I could operate this world's largest planer-type milling machine.
Jiang Lishang dips his finger in the iron filings on the floor from time to time and observes them carefully. What can they tell him? It turns out that alloy cutters generate heat when cutting metal surfaces, and iron filings take on different colors after cooling down from different temperatures. If the temperature is too high, that means a cutter is being pushed too hard. By observing the color of the iron filings, Jiang can immediately tell if the cutter is overheating and then make appropriate adjustments. His acquired intuition comes from years of careful attention to the workings of a machine.
We work in 3 shifts. I've been working like this for over 20 years. I arrive at home at 8 a.m. and my daughter gets out of school at 10 p.m. I rarely see my daughter. I feel guilty. There is little communication between us.
The thick-walled seamless steel pipe extruded by the extrusion machine is undergoing final tests before leaving the factory. Ultrasonic flaw detection, mechanical property tests, and a 600 degrees Celsius heat creep test. A pipe bender softens the tough steel pipe. As cooling water is sprayed on it, hot steam rises, and the 30-meter section gradually takes its final shape. Amazingly, after bending, the diameter and thickness of its curved sections are identical to those of its straight sections. Only thick-walled steel pipes, heat extruded by a large extrusion machine, can have such flexibility. The 4th generation primary coolant loop pressure pipe is finally finished.
This super equipment can affect the whole country and market. We've changed traditional casting and forging by heat extrusion, the modernization of traditional products.
Today, the seamless steel pipes made by this machine have been widely used in nuclear power, marine engineering, aerospace, and other fields. They have been an important part of China's transition from a country that manufactures the most to a country that manufactures the best. In Harbin, what started out as a rough steel casting has finally been transformed into a finished, precisely engineered steam turbine inner casing section. Next, it will be shipped to its destination nuclear power plant. And once installed, it will be a key component of the plant's generator, converting the enormous energy released by atomic fission into electricity for delivery to the national grid.
It's the only ultra-large and ultra-high precision planar-type milling machine in the world. Without it, it'd be difficult for us to ensure the products we deliver to power plants achieve our design accuracy.
Not only low-pressure inner casings for steam turbines, but also components like the crossbeams of high-speed stamping machines and undercarriage beams of mining excavators need industrial machine tools that can make them to required standards. One giant machine uses extreme temperature and force to push out seamless pipes of perfect integrity. The other focuses on high-accuracy machining to transform large rough castings into precisely formed machine parts. This is mega equipment from China. The secret to the creation of these engineering marvels is perseverance and dedication, maintained over decades. They are the foundation on which China's future as a prosperous and confident nation can be built.
I've been in this industry for 27 years. I haven't switched to another field.
I've been doing this for 22 years. I'm an excellent welder.
Under my influence, my apprentices are perfectionists too. Denying yourself is an important condition for moving forward. We're developing very fast now. I wish I could live for another 500 years.
The world is undergoing dramatic changes, and China is undoubtedly one country that is changing fastest. If there's an opportunity to document these changes, it's certainly a very meaningful and worthwhile thing to do. Equipment manufacturing is very close to us. We use natural gas to cook meals every day, but we wouldn't think that it comes from the desert thousands of kilometers away. We turn on lights every day, but we never realize that the power comes from the western border area and is delivered to our homes by some mysterious pieces of equipment we don't know about. Our everyday life is maintained by some amazing mega equipment. What equipment can be called mega equipment? And what do we show in the program are vital questions. We've chosen these pieces of equipment in the program from over 60 pre-selected projects. They're all mega equipment independently developed by China, embodying the highest standards of China today.
Among these three giant machines, one dominates a mine, another bores underground tunnels, and the third hoists up enormous vessels. Ultra-high voltage transmission and transformer equipment, hidden in the network's core, is vital to the efficient operation of this supergrid. On the streets, cars developed with 3D printing and manufactured by intelligent machines are raising both performance benchmarks and living standards. This technology is building tomorrow's world today.
I've been doing this for 12 years, and I deal with cross-river tunnels. I've been working on the Three Gorges project for over 20 years. I've been doing maintenance for 39 years. I've been doing this for 30 years. I've devoted myself to it. I've worked on 4 planar-type milling machines over 27 years. I've been in this industry my whole life. I'm 72, and I can still work if needed. I've been in this industry for 20 years. I've been here for over a decade, doing assembly and heat shrink fitting. I've been here since the factory was built. It's been over 20 years.
I've been a welder since 22.
I've been working here since I graduated in 1984. This is the 28th year for me in the forging industry. My father also worked here. I spent 10 years building this rotor. I can immediately tell the location and function of any of them. I've been keeping a record of my work and the technical problems since 1978. I've been working almost every day, including weekends.
This huge machine behind me is the 50,000-ton extrusion machine. It's the largest extrusion machine our country has ever developed. We spent several years on the production of mega equipment. We went to 38 cities and regions in over 1,300 days. We interviewed at over 30 companies, wrote notes of hundreds of thousands of words, and shot over 20 terabytes of video footage. Over 300 people participated, telling their stories to the camera.
The job is not well paid, and it's hard too. But if you take it as a career, you can find joy in installing and repairing machine tools. By the time the clients were due to come and inspect the product, I had been working for 40 days straight without taking a shower. I decided to take a shower. When I was about to shave, someone called me and I cut my jaw. I always double-check everything I do. Under my influence, my apprentices are perfectionists too. There have been times when I've cried because of the huge pressure. I did it silently, and I can endure all the hardships myself. I'm always nervous when installing it. If I fail, that will cause losses of hundreds of thousands of yen. I always get very nervous and sweaty. My social media name is Rest because I want to relieve some of my stress. I've been operating the excavator for years and I love my job. I'll miss it after I retire. I don't want to leave my post. I love it. I love it. I know it. Eventually, it knows me too. That's the bond. In the past, my son rarely talked to me because I spent little time at home. I'm making up for it. I'll work hard and try to make more money. My shift starts at 5 p.m. and ends at 8 a.m. I've been working like this for more than 20 years. I arrive home at 8 a.m. and my daughter's school starts at 6 a.m. I rarely see my daughter. I feel guilty. We contribute less to our families. It's the nature of my job of water power engineering that you may only get home once every few months. They support me.
My daughter is in college. She told me I have a hard job and she'd help me by doing more housework.
As night falls and the lights turn on, another charming night in Shanghai begins. With a constant supply of electricity, the city is as bright as day. No one realizes that a steel dragon is burrowing right under their feet. "1,400 kilometers to the north lies the Wushu mine of Inner Mongolia. In a tremendous pit echoes the roaring sound of a steel giant. In a super factory, transformer equipment with the highest voltage class in the world is being built. More than 400 kilometers north of the Xiangjiang River, a marvelous lifting show is being staged. Smelting, casting, heat treating, induction quenching, machining. Each process is a challenge. For the creators of mega equipment, behind every success lies decades of perseverance. From a world-renowned orthopedic surgery robot to amazing 3D printing, from the heart of great ships to the West-East electricity transmission project, from the heart of nuclear power to the West-East gas pipeline project, they all have a common name: Chinese equipment.
My parents are farmers. The age difference between me and my father is about 30 years. But I feel like we're 100 years apart in terms of knowledge because we're developing so fast now. I hope I can live a happy life and our country can be prosperous. The equipment I'm operating is worth over 10 million yen. It's much more expensive than the fancy cars that other people may drive. I don't have privileges. I just do my job. Temperatures here can reach nearly 400 degrees Celsius. My privilege is that I can eat as many ice creams as I want. Others can have 2 or 3, but I can have as many as I want. From a negative perspective, robotic assistance negates a doctor's skills. But I think that when you have reached your limit after years of effort, denying yourself is also an important basis for moving forward. I'm willing to lead young people to achieve this dream together. I will keep working on this product for my country. I think it's worth all the hard work. If God allows me, I want to have another 500 years. I will not only improve China's crankshaft industry, but also help develop the whole shipbuilding industry of China.